must say one thing before moving forward about the previous panel. I heard the word doctor so many times during this panel, and here's a doctor standing in front of you. And this doctor, you're speaking a lot about electronic communication. I went to learn medicine because I enjoy direct communication between people. This is the reason why I went to learn medicine. And I'm in this business for long-term relationship, also with my wife, but also with the patient. And I don't know what to tell you, if it will happen, if it's good or if it's bad, but there are some things that you can learn only by sitting in the same room with the patient, getting into, not into his blood test, getting into his mind and understanding what he wants to reach, where he wants to go. And this topic that we are dealing with, and we have started a research program something like 5 years ago, we named it reverse aging. This is the first time that I'm using this name because usually we refer to one specific title or one specific disease. But this is the program, this is the reverse aging. And when we are speaking about reverse aging, we need to understand what we are doing. We have aging. It's happened to all of us. And there is, by the way, a huge question that we will not get into it. The question is getting older is a disease? I'm just dropping you that question and you will have to think about it. There is anti-aging, when we want to stop it, and when there is a reverse aging. And when we are speaking about reverse aging, we are not aiming to immortality. That's not where we are. What we want is we want a good quality of life. What we want is that we want that when we are going down, and we all going down, we want to go down with our heads up. That's the way I want to go to. And this is our mission. When we speak about anti-aging, you know that everybody tells us what we need to eat, we need to do sports, we need to be relaxed, we need love, we need all the good stuff, maybe we need also some chemistry. But when we are speaking about reverse aging, it means that we need to do regeneration. It's not that we are stopping the normal progress. We need to translate it. We need to do something else. We need to go back. And backwards means regeneration. And how do we do regeneration? And this is a question we ask ourselves. And in order to answer this question, we went to see what we have in nature that is capable of doing regeneration. And there are some plants that do it perfectly, and there are some animals that also do it perfectly. There is the salamander. I don't know if you remember it. It was mentioned before in the lecture on the stem cell, and the stem cells lecture was excellent. You can see that if we cut the leg or the hand, it generates a new thing. So if you want to reach that, you need to stepwise it. You need smaller targets in order to reach the big target. And if we want to do regeneration, what we will need a trigger, because otherwise there will not be a need to do something that demand energy. Of course, we will need the omnipotent stem cells, which is the stem cells we spoke about. We will need energy, because any process needs energy, and we will need a supporting environment. All of us, if we don't have a supporting environment, we are all going down. Let's start with the trigger. You can see that if you can take a plant and you can change the location of the light, you will see that the plant will go into the light direction. We also have direction in our body, or the animal's body. We can measure it by electric measurement. What we need, it was well spoken, it's the omnipotent stem cell. This is the salamander. What the salamander is doing before generating a new hand or a new leg, there is something like this. We call it blastoma. And in the blastoma, we have a lot of energy, a lot of oxygen that is going inside, and we have a lot of omnipotent stem cells that can differentiate into the different things that we needed. That's what we want to do. So how do we do it in humans? We spoke about the stem cells. We spoke about the ability to take stem cells from our body, replicate it in the lab, and then inject it. But we have to think more. We have to think ahead. And the question is, can we stimulate our body to generate and mobilize stem cell? Is it possible to stimulate the person, not to take it into the lab? If we can do that, it will be excellent. And we can do that. One of the ways to do that is by taking a patient and giving him a step function of oxygen, meaning increasing the blood oxygenation from 100, where we are now, to something like 2,000, 1,500, and then taking it down. This step function will cause an increase in the mobilization of the stem cells. And what you see over here, this is a group of patients that are going into the chamber. You can see before and after they are going into the first session. You can see the increase in the stem cells in the blood. Look what happened after 10 sessions and after 20 sessions. It's a huge amount. It's like an embryo from the amount of stem cells that are going in the bloodstream. And it's staying there. And it's a dose effect. If we are increasing the amount of oxygen, we will get more stem cells. Of course, there will be a certain point when we will reach toxicity, and we don't want to be there. And it's not only in humans, it's also in horses. Why you see so much work in horses? Because you have the horses that are racing. Some of these horses are more important than human beings. They worth more, okay? Because they are good racers. The environment. The environment is of significant importance. Think of this embryo. Take him out, and nothing will happen. And also during our development process, take the child and put him in an unsupported environment. What you will get? So the environment is very, very important. And if you want to do something, we want to start with the hard thing, the hardest thing to do. And the hardest thing to do is the brain. And if we want to generate brain tissue, we have to understand the environment. So let's get some fact on the brain. The brain is up here. It's 2% of our body weight. But it uses 15% of the cardiac output. It takes 20% of the overall oxygen consumption. It takes 25 to 30% of the overall glucose consumption, which is unbelievable. It means that if you want to do diet, all you have to do is think a little bit more. Okay, that's the best way to do diet. It's more than running, more than everything. Okay? Another important fact. It doesn't mean that you don't have to do exercise. You should think during doing exercise, which is even better. Another important fact, at each time point, the brain up here, we have millions of neurons. But at each time point, only 5 to 10% of the neurons are active. And you should always ask the question, the simple question, why? This is my small child asking me all the time, why? And then you give answer, and then there is another why. And it never stops. Okay? So why we are using only 5 to 10% of the brain? You know what the answer for that? We don't have oxygen for more. We have the blood vessels over here that are supplying oxygen to the brain. And what the brain is doing, at each time point, he's using everything. It means that if I'm moving now the hand, there will be a blood flow to the location of the brain where the hand is moving. If I'm using the leg, it will go to the leg. If I'm speaking on the cellular phone, I will miss the tone. Why I will miss the tone? Because the blood flow is going to the location where the cellular phone is active. If I'm going out of the car and I have some children in the car and I'm speaking on the cellular phone, I will forget the child in the car. In Israel, it's catastrophe because it's very hot. And every year we are losing children that are being forgotten in the car. By the way, it's only males. The woman never forget, the mother never forget the child in the car because this is in the stem cells, okay? Not like us. If we are speaking on the cellular, we are forgetting the kids, we are forgetting everything. So this is the reason. It means that if we have injury in the brain, just by living, we are consuming all the oxygen, all the energy. So there is nothing left to the injured tissue for the regeneration of the tissue. Is that clear? Things are simple. Let's see. Everything we know today about treatment in neurology came from this article, which was not long ago, 1977. It's a long time if you are speaking about what you are dealing over here, but in medicine, it's not so far ago. And what this researcher found, they took patients after stroke, and they have demonstrated that after stroke, there are several degrees of brain injury. The most severe is necrosis. And in necrosis, you don't have anything. But surrounding the necrotic tissue, there is a tissue that have enough energy to stay alive, to keep the membrane potential, but doesn't have the energy for the full activity. To make it simple to you, it's like sleep of the computer. It's like sleeping, okay? Got enough energy to stay alarm, but not more than that. And this is where we are aiming today. This is the tissue we want to activate. Today we can see it. We can see the tissue with a brain imaging. We can see the activity, and we can see the dormant tissue that can persist for years after the acute injury. What's unique to this tissue is that the energy in this tissue, it's anaerobic. This tissue don't have oxygen. That's why it doesn't have the energy needed. So can we change the environment of the brain? Yes, we can. Yes, we can. We can do it. We spoke about the hyperbaric chamber. What we are doing in order to increase the amount of oxygen, oxygen is a gas. It means that the molecules are moving in the space. So what we need to condense more molecules per square. And if we are condensing more molecules per square, it means that they will hit the side more. And you can measure that as pressure. But not the pressure is important. The pressure means that there are more molecules of gas currently inside. That's what it means. Okay? By increasing that, we can increase the amount of blood, of oxygen we have in the blood. You can see on the right side, that's what happened in the hyperbaric environment. And this oxygen, we are increasing the oxygen. We have enough for our maintenance, but also for the regeneration. Does it work? It works. Otherwise, I wouldn't be here, yes? But to demonstrate to you that it works, when we want to measure something in the brain, we need the permission to attack the patient, meaning to get transducer inside the brain. And in order to do that, we are taking the most severe patient. We're taking the patient with the severe traumatic brain injury, okay, where we have the license to attack them directly. And we are measuring the oxygen in the brain. And what you see over here, this patient, I don't have how to let you see it, but this patient with severe are going into the chamber, and we can see the increase of oxygen in their brain, and it persists for 5 hours, 6 hours, 8 hours after they are going down. And once we are increasing the oxygen in the brain, we see that the metabolism of the brain is going up immediately. It's like, if to compare it to something from our area in Israel, you know, it's like you're walking in the desert and you cannot walk anymore. You don't have enough water, and then you get dizzy. Then you get water, and you can start running. That's what happened over here. Once you are giving the oxygen, every bit is being running faster. If we will see different researchers focusing on the hyperbaric effect of the brain, you will see that many things are happening. Some groups are focusing on the brain barrier, some focusing on a specific neurons. But what's happened over here is this. We are bringing the energy that is needed for the rehabilitation, for regeneration of the tissue. The body can do amazing things. All we have to do is let him do it. We have to change the environment so he will be able to do it. Look at this. You're closing the eyes. If it was MRI, nobody would have closed their eyes. What you see on the right side, it's somebody that have non-healing ulcer in the leg. And by looking at it, we can say that the toe is completely lost because we have necrosis. But the other tissue, if we will bring more oxygen, will be healed. What you see on the left side is the brain. But you see it in a non-sterile way. You are looking directly on the tissue. And then you can see that it's the same ulcer. But this ulcer, it's in the brain. We are not used to looking directly at him. We cannot smell it, okay? We cannot feel it, because we see it sterilely, electronically by the computer. But this is what it is. And same thing will happen over here. If we will bring more oxygen and stem cell, it will regenerate. I will give you an example. I will not let you see too much statistic. The best is with example. What you see over here, this is the method that's been developed in order to see the metabolism in the brain. On the left side, this is a scale with the lower part represent necrosis. So this is the SPECT scan of a 62-year-old woman who had stroke, who cannot move her right side of the body. She has paralysis in the right side. In the big circle up there, you can see before treatment and after treatment. The green area is the metabolic dysfunction area. So she cannot move the hand, and then after the treatment, the hand is moving, and we can see the activity regenerate in the brain tissue. She couldn't speak. This is the blue circle. She had complete aphasia. She cannot speak at all. And after the treatment, you can see that she's not only speaking, she also sings, okay? And this is the area responsible for her speaking capability. Now, this, like, for me, it's unbelievable. It's a science fiction, because I was told in medical school that this thing cannot happen. But look, it happened, okay? Another example, no, it's not for me, it's for him. We are only doing small things. We are only giving the opportunity, and things happen, okay? This is another example. What you see in the blue, it's a necrotic area. Now, the necrotic area doesn't change. It stays the same. What is changing is the surrounding. Why is so important? Because you can sit in front of the patient, not by electronically. You sit in front of the patient. It happens. It still happens. I still do it, okay? You sit in front of the patient, and you can tell him, I don't think that your hand will move, but there is a good chance that your cognitive function will improve. And then this patient can say, okay, if my hand is not moving, then I don't want the treatment. And there are other people. I must tell you a story. There is a rabbi, very famous rabbi in Israel, that had a stroke. You know, rabbi, it's a big personality in Israel. So after he had a stroke, and we had this result of the study, one of his students came to me. It's not one. It's a group of his students came to my center and told me, dear Dr. Efrati, you don't know what happened. We need you to come with us. I said, okay, why do you want me to come with you? He said, there is a very important issue that you need to see. I said, okay, what's the issue? We have somebody very important that is sick. I said, okay, bring him here. He said, no, I cannot bring him here. He's a rabbi. You know, the rabbi is like the son of God. So there is no chance that his brain is being injured and he cannot speak or read and things like that. At the end, they brought him to me, and after the treatment, at the beginning, he couldn't read a word, which is frustrating for him, completely frustrating to him. At the end of the treatment, he wrote a book. I'm not saying his name because he's very famous. He wrote a book, and from time to time, we are sitting together at the evening, and the talk with him are excellent. He's unbelievable smart. It's amazing. And we are sitting together, and one of the time we were sitting together and we were discussing philosophy. I told him, listen, you always speak about your cognitive function, but look, you are walking again. And he told me, this is not important. You have to think about it. And there are some people that are saying, if my hand will not move, then I don't want to get the treatment. And they are completely fucked. We have done another study, this time focusing on memory function, and we can see that it's also been improving, and we were able to map, since we have patients now that have abnormality, and then they get normal, and we see the brain imaging, we can compare it and then map the location of the brain that are responsible for different activities. So we do it with that. We did it with traumatic brain injury. By the way, the mild traumatic brain injury are the most, I don't know how to tell it. Mild traumatic brain injury, it means that you had, for example, a car accident, and your brain was moved like this. Okay, it's called whiplash injury. What happened in the brain? We have a cortex and we have a medulla. It's a different density. And if the head is moving like this, it means that you will have different velocity between the cortex and the medulla. And you have blood vessels in between. In 30% of the patient, the blood vessels are being injured, and this patient will not recover. Okay, because they have, Michael Schumacher is severe traumatic brain injury. Okay, but mild traumatic brain injury meaning that they don't have any motor dysfunction after the injury. All they have is cognitive dysfunction. Why it's so frustrating? Because the normal MRI and the normal CT looks normal. The standard MRI and CT looks normal. The only way to see the injury is by metabolic evaluation. And why it's frustrating? I had a discussion last week with somebody here in Europe who is one of the leading insurance company, not the one that hosts us over here. Okay, he told me there is nothing like this, like post-concussion, which is this. All the patients that have it are lying to me. I told him, why do you say that? He said, I have a proof. I said, okay, give me the proof. He said, look, if you are looking at the Far East or the developing country, you don't have any post-concussion in this country. I said, yes. If all your work that you need to do is during the day is to take something from one place to the other, then that's okay. But if you need to work with your brain and your cognitive function are impaired, then you get out of work, out of society, out of everything. So this patient, we are losing them. And it's very important to see the metabolic imaging of the brain. And when we are looking at the metabolic imaging, look at this example. This is a 52-year-old woman that had mild TBI. What happened to her? She went out of the bus and fell down. She had brain injury. And because of this brain injury, she couldn't function on the daily routine. She was a lecturer in the university. She couldn't write. She couldn't eat. She couldn't do the laundry. She was lost. You can see her cognitive function before the treatment, and look what happened after the treatment. She went back to teaching in the university, working, and what you see over here is the change in the metabolic function. What happened to this woman is the same thing that happened here. The insurance company told her, you are bluffing us. You want to get the compensation. Okay, so this is a very important issue. We have done it in anoxic brain damage, but here we are not here to discuss this. Here we are discussing the aging brain. And what is the aging brain? Can you activate the video? This is an excellent work done in the US. What they have done, they have took people, healthy people, 75 years or older, and completely normal. None of them have the stroke, okay? And they did a weekly MRI to them. Okay, every week they done MRIs. Amazing, okay? Amazing. And look what happened. This is on a weekly basis. Whoops, this is a stroke. Disappear. Another stroke. Disappear. Stroke is an ischemic event, okay? It's blockage of the blood vessel. Look what happened over here. It's amazing. What we see over here, we see tiny strokes, tiny ischemic event that happen in the brain. The people, they are not patient. They're supposed to be healthy. They don't feel anything. The only thing that happened is that we see some of the changes that you see over here in a specific unique MRI. And what these people feel is that they feel a gradual decline in their cognitive function. That's it. They remember a little bit less, but it's not a cut point. They continue with their routine. This is the aging brain. And this is the things we need to reverse before we are getting into a point which we call complete dementia, that we cannot function in the daily routine. We should start with this. You can stop that, and we can move forward. So, can we do that? Can we reverse the aging brain? We must. And we can do that by generating new blood vessels, by angiogenesis. That's what we need to do. How can we induce angiogenesis? In order to induce angiogenesis, we will need energy, because we need to build up new blood vessels. Another thing that we will need stem cells, of course, and we will need the trigger. So let's do it. We know how to do it now. If we know how to stimulate the stem cells. We are doing the step function of the oxygen, and we are stimulating stem cells. So we know how to do it. We need a trigger, and this is very interesting. One of the triggers for inducing blood vessel is hypoxia. But what the body feels, it's not the absolute level. The body feels the changes. Okay? Everything is relative. We will say that we are good or bad compared to our environment. Okay? Think about it. 100 years ago, nobody had a car. The rich people, the wealthy people didn't have a car, but they felt very wealthy. And today, if somebody is not able to buy a car, I'm saying car because we spoke about cars today, he's feeling very poor. So everything is relative, also in our body. If we are taking a patient, increasing the oxygen, and then cutting it down very fast, what the body will feel, he will feel the hypoxia, even though it's not hypoxia because we went up. And he will secrete in the tissue. There will be a secretion of HIF, which stands for hypoxic inflammatory inducible factor. Hypoxic inducible factor, and here you are looking at the brain of mice and rats, but this is the brain of mice where the HIF is being induced even though we are increasing oxygen. And we can see, because we have the trigger, the HIF, because we have the oxygen, and because we have the stem cells, we see new blood vessels in the brain of a mice. But we are not mice. Okay? At least not the brain. The brain is a little bit different. I sometimes write a book, We Are Not Mice, and put a mice near in front of the man, and because all the research today is being done on mice and rats. What happened in human beings? Look over here. This is a perfusion MRI. We can see the blood flow of patients who had traumatic brain injury. The upper line represents what happened before treatment. They are 10 years after the injury. The middle line represents after the treatment, and the bottom line represents the data. Everything that is in red is 40% improvement, yellow 50% improvement, etc., etc. You can see that we have new blood perfusion, new blood vessels, and it means that we can induce angiogenesis in the human brain, which is amazing. Now let's go back to what we want. Can we reverse the mild cognitive impairment? What you see over here, I chose to bring that. This is a very important man in Israel. He's a 65-year-old guy. He's a CEO of a high-tech technology. I will not say his name because many of you will know him. He came to me and he told me, Shai, I need to meet you. I said, you need to meet me. Come, let's drink a coffee. He came, and he told me, Shai, I'm not good. My cognitive function are not good. I said, what? Your cognitive function not good? Look what you are doing all the day. It's amazing. He said, no, I'm not good. I used to remember 24 numbers sequentially, no matter what you tell me. Now I remember only 10. I told him, I don't remember even 5. So you remember 10, then it's great. He said, no. For me, it is a decrease. Told him, okay, let's do metabolism, brain imaging of the metabolism of your brain. And we did it. And the upper line, you see it. And since it was abnormal, we gave him the treatment. This is after the treatment below. And again, what you see in the bottom line is the change. The black area are the ones that are stay the same. The yellow are up to 10% improvement. red, 20% improvement, and white, 30% improvement. In addition to what you see over here, he repeats to remember, he gained his memory back, and now he's remembering again 24 numbers in a sequence, which is amazing. So everything is relative. For him, it was the starting of the decrease. And what will happen now, every time he will go down from 24 to 20, he will come and get a booster to gain back to 24. So we think that this is the real brain. But in males, this is the small brain. The big brain lies down here. Okay? This is the real brain of the males. And erectile dysfunction, it's something that is also related to blood perfusion, okay? To oxygen supplement. If we want to get erectile, it means that we have a good blood flow. If we don't have good blood flow, it will go down, okay? Or at least will not be as hard as needed. So this is a major problem when it happens to you. And what you see over here, it's the same thing, okay? What you see over here on the left side, you can see the penis with the blood flow before treatment of somebody that has erectile dysfunction, meaning his erectile was not hard enough. This is before treatment, after treatment, and down here you can see the delta. And you can see the new blood vessels that were generated in the real brain of the human being. Okay? This is a new brain, and now he has a good erection. And this is another cut you can see, that once the angiogenesis was generated, there is erection. And everybody is happy. And this is more important to many of the men than remembering 24 numbers. Okay? So, we can do reverse aging. We cannot stop our timeout when it comes. We cannot stop the clock. It will happen. But what we need to do is to go up like here, like we are standing now. When it happened, it happened. Until it happened, we want to function well. We have demonstrated the brain. We have demonstrated the sexual function that we can reverse. And the next steps will be that we are working on now is the bones, heart, kidneys, and skin. If we spoke about the skin, for females, we are doing a research about the skin. What happened with the skin, it's amazing. It's the first time that happened to me in life. When I get back of the office, when I get the permission from the Helsinki committee to start the study, I went up and told my secretary that I have the Helsinki approval to starting the study. What happened? I was the most wanted man in Israel. 5 minutes afterwards. And 2 days afterwards, my mother called me, Shai, what's going on? I heard that there is amazing thing going at your work. Finally, something good is coming out of you and you don't tell me. So this is the skin in the human being, in the female. So for the male, it's probably the erectile dysfunction, and the skin is for the female. So these are the things that we are working now, and we hope to succeed. I'm standing in front of you, but currently there is quite a large multivariant group that's working on this project. I believe in working together, people that are coming from different disciplines, that coming from physics, math, philosophy. The physicians in this group are the less smarter one. We only look that way, but we are not. So this is the group that is working, and we hope to bring you good news. Thank you very much.